Hello everyone and welcome back to this video. Now in this video we are going to discuss about head versus tail recursion. Now in the last video I gave you an idea about what exactly head recursion is and what is tail recursion via print 1 to n and print n to 1 question. But I would like to discuss a little bit more about the same so that you are able to clarify this and solve the question more effectively going forward. So let's get started. First let us talk about head recursion. Now in head recursion, as we have already seen, what happens is that we are making the function call, we are making the recursive call at the beginning or once we have actually defined our function. So that is where we are making our function call. So we make recursive call at the beginning of our code, right, of our function implementation. Now let us see an example of this. That would be a lot helpful to understand it a lot deeply. So let's say if I have factorial of a number only and factorial head, okay, and I'm getting a number. So if my n equals 0, I know this is the base case, so of course I can return 1 here. That is understood. Now when I'm actually, I would say, discussing about what I should do, I used to have this small answer. So I'm making this recursive call here where I'm capturing this small answer, right, with n minus 1. And then I used to do some calculation. So I would write this as final answer. And in my final answer, I used to multiply my small answer with this, right? So this is how we have actually broken down each and every step in recursion for better clarity. And then of course, finally, I used to return my final answer. If you will see in this particular question and implementation, you will actually see that we have call the recursive first and then we are also doing some calculation, right? So some calculation we are doing at our end. So whenever you are doing stuff like this is actually known as head recursion. So let me just clear everything and let us move on to the tail recursion if this is clear. So we can just call factorial head and let us use 5 and I think it is running. We just have to print it as well. Yeah, so if I just print it now as well, we are getting 120 as an answer, right? So now let us move to tail recursion. Tail recursion, of course, as I would say in comparison with head recursion, is when we make recursive call at the end of our implementation, right? So end basically means tail. So whenever we are doing something like this, that is what your tail recursion is. Now let me explain you this also via code. So def factorial tail n. So I'm going to copy this base case from here. This is going to the base case. And what I can do is I can return n into factorial tail n minus 1, right? So this actually is the most common mistake with many students do. You might be thinking that yes, we are calling the function in the end, but actually that is not what is happening. To, I would say, actually find the answer to this whole line, right, which you are returning, you will have to first make a call. And once you get the answer, then is when you will be calculating this full expression and returning the same. So in a way, as we were doing in head recursion, where we were calling our function, making the recursive call, waiting for that and then calculating the answer, we are actually doing the same thing here. It's just that it's disguised in less lines. And this is actually the kind of mistakes which I want all of you to avoid, right? Because these are the something which help you to make a become a better programmer. Okay, so this actually is wrong. I will just specifically have written this thing, and this is a wrong implementation of your tail factorial tail recursion. You have to understand one thing, that see, in tail recursion we have to make sure that we are just making the recursive call. So just calling the function. We will not be doing anything after that. We will actually not be doing anything after that. So now if I write factorial tail, exactly how that will be written is, in this particular use case for factorial number, we actually will have to use something known as accumulator, Okay, so it's just a terminology. Accumulator actually what is it is. So I hope you are aware of the parameters as well as the default parameters. If not, please make sure that you see the videos in this course only. We have defined, me and Krishna have actually properly made sure to define what exactly are parameters and then default parameters. So here what we want to do is, if let's say my n is equals to 0, right? If my n is equal to 0, then I can just simply return my accumulator. So this is having my answer. This is accumulating everything, right? This is, I will repeat what exactly it is doing. It is accumulating each and everything. Okay, so when my n is 0, that is the base case. I'm just going to return my accumulator, which is the default answer, which is going to be 1. But if that is not the case, I'm going to change my accumulator and multiply it by n. And this is now, see, now I'm just making this call. So I'm just returning factorial tail n minus 1 and accumulator, which I have changed, right? Now, if you will see the line number 24, actually, here I am now not doing any calculation. I am not doing any calculation at all. I am just called this and it's going to return me the answer. And if you will see, accumulator is going to get returned, which is, so see, initially accumulator is going to be 1, right? If we take for, let's say, factorial tail for 4. Now when I will move forward, accumulator first going to be equal to accumulator is going to be 4. Then in the next call, accumulator is going to be 4 into 3. So let me just actually, it will be better if I showcase this to you in Python tutor, because that will help you to clear out all the doubts. So let us see this once, everyone. Factorial tail. And please make sure that you understand this very, I would say, deeply, because it is a very important concept, right? This is the actual, I would say, difference between your tail and I would say this head recursion. And this is different as well. Like many students I see, they just have the knowledge that you are calling tail, like in the starting you're calling the recursive call, then it's head recursion. In the end, it is tail recursion. But there are some more caveat to this, which I'm going to explain. So first, let us understand this particular program. Pay attention, everyone. So once this fact tail is basically getting defined, and default argument is accumulator, which is having the value as 1. Okay. When I move forward, first I'm going to check if n is equals to 4. That is not the case. But now I'm changing my accumulator, right? So in the accumulator, I'm actually accumulating all my answers. It's going to become 4. So my accumulator becomes 4. Let me move forward. Now the next call, if you will see, factorial tail, my accumulator is actually 4 here and n is going to be 3. Now it is still not having the base case. Accumulator, now it's going to get changed into 4 into 3. Okay, so if you will actually see, we are building our answer, right? We are building our answer in the accumulator, and that is something which will finally get returned. So pay attention. Now this is also basically done. For n is equals to 2, again we are going to do the same thing. Accumulator is going to give me the answer, which is 24. And when I move forward, now pay attention, everyone. This time n is equals to 1. Accumulator is having the answer 24. It is still not the base case, so I'm going to multiply and going to call for 0. Now, when this is the base case, pay attention. Now what's going to happen? This function is going to say, hey, return whatever there is in the accumulator. And I know that in accumulator, my answer is actually there, which is 24. And it will return it. Now, in this particular line number 7, for n function with n is equals to 1, I'm not doing any calculation, right? I'm not doing any calculation at all. So, this is just going to return whatever answer I'm sending it. And it's going to just get returned. Going to get returned, return, and return. So, this is actually tail recursion, where you are not doing any work after making the recursive call. If I would have doing any changes, any multiplication or any operation for that matter, that would not have been tail recursion scenario then, right? This thing is very, very important to understand, and that is where most students make the mistake, where they say that this wrong implementation of tail is the tail recursion. Now, if I will just show you the full working as well, see, it gets returned, return, return, return. We are not doing anything, right? We are not doing anything at all, and we have gotten our answer. Now, an obvious question which will be there in like your mind is that why are we actually doing it like this? What benefit are we getting? So the answer for that is that normally tail recursion is actually a lot, I would say, optimized. Okay, it takes a less memory in stack as compared to your head recursion. Now Python by default actually not uses this optimization. Okay, but what happened in some other languages is that when you know that, okay, we are implementing something using tail recursion, there what happens, what exactly happen is that the stack doesn't save the previous function. So if we saw here, like the way we saw here, just visualize it once again. Let me just call it, yeah. So all these functions, because they have done their work, perfectly, stack will not be storing these functions, and instead, see, the understanding is that whatever I will be getting from this particular call in the line number 7, I have to return that, and this particular function has done all its work. So what I do is what some languages do, and Python can also actually do that. It's just a little bit complex. Okay, by default it doesn't do it, but you should be aware of that, because tomorrow if you're making a function which is, let's say, going a lot deep into a recursive tree, then tail recursion is always better. It is more optimized, and it is, I would say, overall takes a lot less memory. All these functions, they will not be stored actually in your stack memory, because it doesn't matter, right? We just have to, I would say, return whatever answer I'm going to get from the, I would say, final thing. Okay, so the way I can explain you, so now I hope you are able to get the basic idea of what head and tail recursion is, along with, of course, the definition. Okay, so it is more than just making the recursive call. There is, I would say, an optimization also involved. But now let me explain to you this intuitively as well, so that tomorrow, if you want to explain this, let's say, to a 13-year-old, how are you going to do that? Okay, so just go back to your school once with me and think of a use case. When, let's say, you are attending an extra class towards the end of the school or your college, and let's say each and every one of you have to do some work, right? Each and every one of you have to do some work. The first case is when you have to, let's say, fill in an homework in your notebook. So you are filling in homework in your notebook. Okay. So in the head recursion, what exactly is going to happen is that, one second. In the head recursion, you are first going to make the call. That is what we do, right? Head recursion. First going to make the call to the second one, then this person, and then this person. So your call is going to get made to each and every, I would say, person, and you are going to stay till you get the answer, right? Maybe you want this copy. Okay, maybe the teacher has given you the work that, hey, collect all the copies and give that to me. Now you are saying that, hey, first I'm going to collect these copies from everyone behind me. So you make the call to this particular person, the second person, and you say, hey, get me all the copies. It makes the call to the third person, it makes the call to the fourth, and the final, and the fifth person. Now, of course, you have not submitted your copy yet, so you will be actually waiting in the school, you will be waiting in the memory, right? This person is going to return its copy, so it will have 2 copies. It will return both the 2 copies, so it will have 3 copies, and like this. Once you get all the copies, all these, I would say, after returning their copy, they will be good to just go. Okay, and once you have all the copies, you're going to submit that to be, let's say, your teacher. Okay, but vis-a-vis in tail recursion, what's going to happen is that you can actually give your copy to this person. Okay, and that is what we are doing, right? We are doing our work first. And then calling the next function. So I'm calling the next person and saying that, hey, take my copy, take all my work. And now if you think about it, you don't need to stay in school, right? You can go back because you have actually done your work. And the same kind of a thing actually some programming languages does, and we can even make Python do that. Now, of course, that is out of scope and a little bit complex, so not covering that. But you should be aware of this from interview point of view as well, that yes, tail recursion actually helps you in this kind of optimization, where now once you have submitted your copy to this particular person and he has 2 copies, you are good to go because you don't have any work. And this is the kind of optimization which a programming language does, where if there are lots of, I would say, recursive call, and if you have done tail recursion, if you have implemented tail recursion, then via tail optimization, we don't save those functions, those intermediate functions in the stack memory, because actually they have done their work, and whatever answer, whatever this final person will basically be giving, that is going to be your answer as well. See, you were required to give all the copies. You give this copy, and this final person will actually give all the copies because he will be getting the copies from everyone in front of him. Okay, so in this manner, actually now 1, 2, 3, 4, once they have done their work, okay, once they have given their copy, they don't need to stay back and they are good to go. Okay, I hope that this intuitive example is actually a lot useful in understanding this, that how internally language also, think, and actually they're able to implement or optimize the, I would say, overall implementation. Whatever implementation we have done, what effect does it has? Okay, so that is actually head versus tail recursion. Just one thing, always remember, this is not tail recursion. We are still gonna wait and then do it. This exactly is tail recursion, but here many times we might have to use some accumulator which is going to save our answer. In this particular use case, the one which I've given you an intuitive example, this is actually an accumulator. So I gave my copy to this particular person. There two copies are there, then there are going to be 3 copies. So my copies are getting accumulated. In the factorial example which I gave, my answer was actually getting accumulated. And in the end, I will just return all the copies. So just they're going to get returned, right? So it doesn't matter even if I'm not there. And if this person is returning the copy, they're going to go to the teacher. Okay. So yes, I hope with that you are able to understand head and tail recursion a little well. I made sure to cover it a little bit more deep so that, you know, from interview point of view, you're all set and you don't have this doubt that there is no difference if you're doing it via head recursion or tail recursion. Okay. So going forward, we will be trying to code with both the ways. And now since you know the difference, it should be fine. If you prefer, I would say tail recursion a little bit, but of course some questions will be there where head recursion is the answer and that should be fine. But you should be aware of this particular difference. Okay. Cool then everyone, let's meet in the next class and we are going to now start with recursion and arrays and solve some awesome problems after understanding how recursion can be used with our arrays all list. Okay. Thank you.